Hello everyone, I'm going to be reviewing this video, Voted Best Flat Earth Proof 2017. They're going to start out with some actors talking about faith versus, science. And I'm not going to go through that section because it's just emotional, and I agree with what you guys are trying to say here, that you shouldn't take scientists at their word 100% of the time. But you should have some skepticism. However, I personally know that the Earth is round, not because I trust scientists, but because I've done the numbers myself, as he asked in this skit. And I know that the flat Earth model doesn't work, and I know that the round Earth model explains many things that cannot be explained on a flat Earth model. So, let's move onward. Just say yes, don't trust scientists, but I do know that the Earth is round.
Oh, interesting.
Let's go on. Okay, so we get past the actors and scientists admitting that they're not perfect, and we get to this well-spoken flat earther who is about to explain that moonlight is cold, and therefore the heliocentric model is destroyed. I think that that's kind of remarkable that he thinks it should destroy the heliocentric model. Why exactly? You guys have all sorts of alternate explanations for phenomena that we throw at you, and the idea that there is no alternate explanation, even if moonlight is cold, on the globe Earth model is kind of remarkable. And another guy is going to talk about how the size of the sun and the moon are exactly or close to exactly the same as we look at them, and that the moon always faces the Earth. And somehow that doesn't work on a heliocentric model? Of course it does. Of course it does. So I'm going to go past this whole section, try to get to what I consider more valuable. Okay, so an airline pilot who is a flat earther. Let's hear what he has to say.
The pilot's primary flight instrument is his artificial horizon.
Okay, he's talking about the artificial horizon, which is this thing here. And because he's a pilot doesn't automatically mean he knows how this thing works. But the general idea that a flat earther usually talks about when they're talking about this artificial horizon is that it's a gyroscope, and as a gyroscope it should maintain its level as you go over the Earth's surface. And that's actually true. Let's go look at this thing right here. This is a video put out by the Navy. As you can see, they're actually showing in this picture that very thing. Even though this instrument has moved, this section here maintains its level. Let's just listen to, and they call this apparent drift.
Surface. In order for the gyro instrument to be dependable, drift must be corrected continuously. There are several types of erection systems that correct for drift. The principle back of all these systems is based on 3 steps. The direction and degree of drift are measured by electrical or mechanical sensing elements. These elements then control the application of a proper force to the gyro, and it precesses back to its normal attitude.
Okay, so they're saying that they correct this in their artificial horizons, and they do it normally with pendulums. Actually, that's in the olden days. Now there are newer types of gyroscopes that are laser, and they do things a little bit differently. But the bottom line is that these instruments are not purely gyroscopic. They are corrected by other instruments to help deal with this apparent drift. And the fact that a pilot doesn't know it is not, I don't know, you shouldn't be shocked. Okay, so he's saying he's up here high up and it doesn't look too round, eh? Well, he says himself that he can see for several miles, or several hundred miles, and that there is no visible curvature. Well, let's look at a picture of several hundred miles on this model here. Well, it's small, right here. You know, maybe from here to here. I'm just guessing. But it's not very far. And so even when you are up in a plane, any curvature you can see is very subtle. Some people say that you should be able to see some curvature starting at, 35,000 feet or 50,000 feet. But once again, it's subtle. Doing the math, it's like a degree and a half, or 2 degrees of curve that you could see. And that could be entirely canceled out by how your brain thinks. So I'd say that being up in a plane and thinking that it looks flat is not very good proof. So let's talk about this picture while it's paused. Number one, they're saying here that the artificial horizon of their plane should tell them that they're diving at this point, but we already talked about that. Number two, they're asking the question, why doesn't he have to constantly dip his nose? Even if this gyroscope is level, why doesn't he have to put effort into keeping this plane going around the curve? Well, there's a couple of things. If he were to continue going straight, he would be heading into higher and thinner air, and to do that, you would need to increase your airspeed or put some energy into it. And of course, he's not doing that. He's maintaining a speed, and it will be natural for him to stay at a given elevation. Also, they make planes nose heavy. It's part of what makes them stable. These wings back here actually push downward, unlike these wings which lift, to compensate and make stable flight. Think about when a plane stalls. Well, what typically happens? Well, the nose typically starts to drop. And if you were to design a plane that didn't have to constantly be pulled upward, you would calibrate it such that, you know, the flight feels natural for its characteristics. Anyway, I find it remarkable that you'd think that it would be anything dramatic anyway. Over, several minutes, you have to correct a degree or something like that. Would you even notice that? I don't know. It's a pretty bad point in my mind. Anyway.
You should be dipping your nose down, and every 5 minutes you should be dipping your nose down to stay around the curve.
It'd be continuous.
That's absolute proof that a plane flies over a flat surface.
And it's not absolute proof either. Alright, let's do a quick experiment real quick. I'm going to take a screenshot here. So, let's see, go over to a program. I'm going to do this thing called Threshold. And boom. Do you see the curvature in this picture? This is in your own darn video. It's subtle, but it's there. It's not my video, it's your video. And now that it's pixelated, you can see it climbing and then falling. So there's curvature in your own darn video. Now you might say that, well, it's lens distortion, but lens distortion works the opposite way if in the lower half of the image. It would be distorting this downward, and so there should be more curvature than this. So if this lens is distorted, there's more curvature than is being shown here in this camera shot. You just have to remember that the halfway point is the magic point where the distortion starts to switch from downward to upward. And so you can still make some conclusions about curvature even from a GoPro lens. And we'll do that again later. Back to the video. So you think that's flat? Well, it's not. Okay, so they're going to talk about evidences that some images are fake or composite. But I don't feel like that's worth battling over because NASA admits that they do composites. There's a logical reason why they do that. They're trying to get a high-resolution photo of a small section rather than trying to get a lower resolution image of the whole thing. If they do that, then they need to paste them together.
And they spelled out the word sex, right, recently, probably a few months ago in one of the clouds.
And even if the images were totally faked, that's not proof that the Earth is flat.
Of Earth, we can't get a view of Australia with the buildings upside down.
That's so ridiculous. I know, they're probably just joking. But still, those are such ridiculous pictures. They're not proof. You know, those ideas that you should see something upside down. I don't know. We're the ones upside down, maybe. How does that look in pictures? It's all relative. So, they still have problems with some rockets. So what?
The trajectory of the space shuttle, it doesn't go straight up.
Here we go.
It always goes in a curve and out to sea.
Okay, let's talk about the path that rockets take. You know, on the globe Earth model, let's say that you go, here's a globe. If you keep going straight up, you're not going to go where they want to go. They want to orbit. So if they want to orbit, they have to go sideways. And so this is a non-argument. They're not interested in going straight up. They do want to orbit, so they have to go sideways. If you were to go straight up, get into space, and then suddenly change your direction, oh, let's take a left turn so we can get into an orbit, well, you would have been wasting time and energy getting up there in a direction that you're not interested in. Okay, we are reaching a critical part of this video. Read that text. That's called the Go Fast rocket. It was launched in 2014 and it set several records for amateur rocketry. It reached an elevation of 75 miles, I believe, which is pretty darn high.
One thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go.
rockets don't have brakes. It's
Okay. Wow. Yes, it stopped spinning. It's very interesting. Let's go look at another video here. Kind of picks up where that one left off. This one is just called GoFast 2014 HD onboard cameras. Let's search the comments. They're like, what was that thud at the end that caused it to stop so suddenly? Did it run out of fuel or something? That was pretty interesting. Search yo-yo D-spin. There's another comment. For everyone who is saying that the rocket hit a dome because it stopped spinning, you don't know anything about rocket science or physics in general, and you seriously need to educate yourself. The rocket performed a yo-yo D-spin, a common simple maneuver in amateur rocketry. It had two weights attached through a string which were let go and stopped the spinning, and then they were released, and then let go. It is an extremely quick maneuver, especially if the rocket is rotating very fast, like it did in this video. You can find many video demonstrations of this technique on YouTube, so you can go search it. But the builders of the rocket did say that they intentionally built it to stop its spin. At the time when it stopped its spin, it had already coasted to a stop in the vertical direction. There was nothing that stopped it in that direction. And yeah, you shouldn't be surprised that a rocket would cancel its spin at some point in order to deal with the payload. If it's going to release a payload, it doesn't want to be spinning like crazy. In this case, it's about to do a separation, and the Flat Earth video conveniently doesn't show it. Now I want you to listen very carefully. This is not the sound of hitting water. It is the sound of that string being released in the weights. Keep in mind that the sound was carried through the body of the rocket. There goes the separation that they despun for. Now let's pretend for a second that it wasn't intentionally despun, but instead splashed into some sort of water. That is some remarkably clear water. And why are you still spinning? Come on, that water's got to use up your momentum at some point. Wow, that's clear water. I just don't see any ripples or shine or refraction. Yeah, you're still spinning. I want to point out a few problems here. Number one, something doesn't just spin forever in water. Number two, you claim that this hit the firmament, but this only ever went 72 miles up. You guys don't think the firmament is at 72 miles. You've got the sun at about 3,000 miles up, and I guess stars even a little further than that. So, no, by your own model, this rocket didn't hit the firmament. It's not even close. Second, if it did splash into some water up here, why did it come back down? I mean, the water's not coming back down, right? Wouldn't it just float around in that water? And third, why does it just keep on spinning? And uh-oh, is that some Earth curvature over there? Let's do another screen capture. Alright, let's use our threshold just to make it even more clear. Yeah, it's curving all right. We can adjust the threshold if we like. Certainly, it is curving. I want to remind you at this point that GoPro lenses would distort the image this way. So, once again, it's even more curved than this is showing, assuming typical barrel distortion. Let's go back to the video and you'll see that barrel distortion. Alright, this is a different camera, side mounted. Clear curvature on this side. You get to the very edge and there's finally enough distortion to bend the curvature away. But get back out here and your curvature is restored. All right.
Although we weren't able to shatter that highest, hardest glass ceiling this time, thanks to you, it's got about 18 million cracks in it. And it may be hard to see tonight, but we are all standing on...
We all know what the glass ceiling means to these people, women in particular. They're talking about people, they're talking about their progress is impeded by culture.
You could make a wildlife reserve 1,000 miles square. All people, all human beings would do is just be knocking on the fence constantly. Why is this fence?
Let's go onward. This is not proof.
Gravity is something we can't see.
More non-proof.
Almost too
With it, but when you start asking, like, what it is, I don't.
Okay, so Neil deGrasse Tyson, famous scientist, is stumbling a little bit over what gravity is. Well, sure. Any question could always be taken deeper and deeper until you don't know the why. Sometimes scientists admit it, sometimes they don't, but it's only logical. Okay, well, I've skipped some stuff that is mostly just trying to hit you at an emotional level. We've come to a portion where they're talking about how ships disappear over the horizon.
Boats don't disappear over the curvature of the horizon. Boats disappear due to perspective. All you have to do is go to the beach, watch a boat disappear from your eye, and then whip out your telescope, your binoculars, or your high-powered zoom on your camera, and you can pull the entire boat right back into view. Whole mass and all.
Okay, so he's messed up his argument here. His argument is that zoom brings the object back into view. But what was originally argued by people like the Greeks and other people who observed at sea is that even through their optics they would see the bottom of the boat disappear. Even though they could see the boat clearly, they could see that the bottom was missing. He's completely missed their argument. Not that they can't see the boat, but that they can see the boat, and the bottom is missing. So what would zooming in more do there? Nothing. You'd still see the bottom missing.
Yeah, that's right.
I find this
Just whip out
pretty bad.
your binoculars or your zoom camera. You bring the entire boat back into view, completely debunking everything Coy just told you.
We've always believed that there
No,
was
no.
I believe in God. I believe the universe was created by God.
realize that maybe Earth is more special than we thought.
Alright, more emotional stuff. Let's see if there's anything else.
This is what we're in right now. This is what we're on.
Yeah, really more emotional stuff. I don't think there's any more proof here. I'll give my conclusions. All of this proof is bad proof. In fact, if you accept the authenticity of that rocket launch, then you have curvature shown to you, and know that it is a ball. The end.